So we continue with this example solving linear systems in 3 variables. And this problem states, to raise money for their middle school volleyball team, players sold candy door to door. The supplier of the candy donated beginner packs, junior packs, and pro packs of the candy. A beginner pack contains 10 Snickers chocolate bars, 8 bags of plain M&Ms, and 6 Kit Kat wafer bars. A junior pack contains 10 Snickers chocolate bars, 11 bags of plain M&Ms, and 18 Kit Kat wafer bars. And a pro pack contains 18 Snickers chocolate bars, 20 bags of plain M&Ms, and 12 Kit Kat wafer bars. If the volleyball team sold a total of 132 Snickers bars, 137 bags of M&Ms, and 120 Kit Kat bars, determine how many of each pack was donated to the team. Now, as we've done in the previous example, we're going to build a table to help organize our elements here, our thoughts here. And the first thing we're going to do is we can see right here how many of each pack. And that's going to be our variables. Those are the ones that are going to fluctuate. And of course, our variables are going to go across the top of our table. And that's going to create those columns related to those variables. And we have 3 variables. The things that are going to fluctuate are the beginner packs, the junior packs, and the pro packs. And of course, now for our rows, the rows are the elements that are in question here. And those are the Snickers bars, the M&Ms right here, and the Kit Kat wafer bars. Also in our rows are the totals. A total of 132 Snickers bars, 137 of the M&Ms, and 120 of the Kit Kat bars. So now that we have all this information, when we build our table, it should look something like this. We have our variables, the values that are going to fluctuate at the top here. Here's the columns for each one. And inside here are the elements. Each one of these is a linear equation. And now that we have that information, we can go ahead and build our system of linear equations that's going to model this scenario here. So we'll have 10x plus 10y plus 18z, that's equal to 132. Remembering that x is the beginner packs, y is the junior packs, and z is the pro packs. Then we have 8x plus 11y plus 20z, that's equal to 137. And finally, 6x plus 18y plus 12z, and that's equal to 120. We close off this system. So this is the system of linear equations that models this scenario here. So now that we have that, we can use this to build our matrix. So our augmented matrix would be 10, 10, 18, put in our vertical line, then 132. Remembering to the left of the vertical line, this is our coefficient. This is our matrix of coefficients. And over here on the right, that's our matrix of constants. Then we have 8, 11, and 20. It's 137, and then 6, 18, and 12. That's 120. Close off our matrix. So now, of course, we're going to use row operations to solve this. We're going to be looking for that diagonal again. We want to change each column into a unit column, creating a diagonal across here, so we'll do that. Now, as we look inside here, there is no element, there is no value in here. That's a 1 that we could target. But if we look very carefully here, we can see right here, this third row here, each one of these elements is divisible by 6. So I'm going to take 1/6 times row 3. So if I take 6 times 1/6, there's 1. 18 times 1/6, that's 3. 12 times 1/6, that's 2. Bring down my vertical bar. 120, 1/6 of 120 is 20. Close it off and fill in the rest of my elements. 10, 10, 18, then 132, 8, 11, 20, and then 137. Now, since this is in my X column here, I'm going to swap these two rows. We'll just change them. So I'm going to take row 1. I'm going to interchange it with row 3. So we'll have 1, 3, 2, put in the vertical line, 20, then 8, 11, 20, and 137. And then 10, 10, 18, and 132. And now I can close off the bracket. And you can see where we swap these two out. Now I have one that's going to start my diagonal here. Now we'll use row operations to either change, target this value here or target this one here. It doesn't really matter where you start. How about if we say row 2, and I'm going to subtract out 8 times row 1. So we'll come over here. 1 times 8 is 8. 8 minus 8, 0. Again, that's the whole idea. 3 times 8 is 24. 11 minus 24 is negative 13. 2 times 8 is 16. 20 minus 16 is 4. Bring down the vertical line. 20 times 8, that's 160. 137 minus 160 is negative 23. We close off our bracket and fill in the rest of the elements. $20, 10, 10, 18, and 132. Now we'll go to this value here. So we'll take our 3 minus 10 times our 1. One times 10 is 10. 10 minus 10, 0. 3 times 10 is 30. 10 minus 30, negative 20. 2 times 10 is 20. 18 minus 20 is negative 2. Bring down my vertical bar. 20 times 10 is 200. 132 minus 200, it's negative 68. Close off the matrix. Fill in the rest. So now we have this as a unit column, so we're done with this column. Again, we don't have a 1 that we can kind of target, but if we look right here, this is all divisible by 2, so if I divide everything by 2, or negative 2, I wind up changing this into a 1, so we'll do that. So we'll take negative 1/2 times row 3. So negative 1/2 times 0, of course, is 0. Negative 1/2 times negative 20, that's 10. And negative 1/2 times negative 2, that's 1. Bring down our vertical line. Negative 1/2 times negative 68, that's 34. Close off our bracket and fill in the rest. 1, 3, 2, and 20. 0, negative 13, 4, and negative 23. Now I'm starting my diagonal here, so I could either target this element here or this one here. So how about if we start with this one here? We'll do row 1 minus 2 times row 3. This will be 1. 10 times 2 is 20. 3 minus 20, that's negative 17. 1 times 2 is 2. And of course, 2 minus 2 is 0. That's the whole idea. Bring down the vertical bar. 34 times 2 is 68. And 20 minus 68 is negative 48. Close off the matrix. Bring over the rest. Zero, 10, 1, and 34. So now we can target this value here. So we'll do row 2 minus 4 times row 3. This winds up being 0 here. Then 10 times 4 is 40. Negative 13 minus 40, that's negative 53. 1 times 4 is 4, and 4 minus 4 is 0. Again, that's the whole idea. Bring down our vertical line. 34 times 4 is 136, and negative 23 minus 136 is negative 159. Close off our matrix. Bring over the rest of the values. Negative 17, 0, negative 48, 0, 10, 1, and 34. Let me bring over my transition here. So now we have this as a unit column. And as you can see, we're building our diagonal here. But as you can see here, all we have is negative 53. So if we multiply this row by negative 1 over 53, or 1/53 times row 2, then this will be 0, negative 53 times negative 1/53, that's 1. That's the whole idea. This winds up being 0. Bring down our vertical bar. Negative 159 times negative 153, that winds up being 3. Close off our matrix and bring over the rest of our values. 1, negative 17, 0, negative 48, 0, 10, 1, and 34. Let's put in our transition here. So now we can maybe target this value here. So we'll take row 1 and we'll add 17 of row 2. And as I put in my transition here, we'll continue that up here in the upper left corner. So this winds up being 1. Then 1 times 17 is 17. Negative 17 plus 17, 0. And then we have 0 here. Bring down our vertical bar. 3 times 17 is 51. Negative 48 plus 51 is 3. Close off our bracket and bring over the rest of the values. 0, 1, 0, 3, 0, 10, 1, and 34. Our last element is right here, so we'll do row 3 minus 10 times row 2. This is 0. 1 times 10 is 10. 10 minus 10 is 0. That's the whole idea. Of course, then this is 1. Bring down our vertical bar. 3 times 10 is 30. And 34 minus 30 is 4. Close off our bracket. Fill in the rest. 3 and 0, 1, 0, and 3. So as you can see, we now have our diagonal of 1s here. Each column is a unit column. If this first column represents X and X is our beginner pack, then there were X is equal to 3 beginner packs were donated. Y is our junior pack, so there was Y is equal to 3 junior packs that were donated. And Z represents our pro packs, so there were Z is equal to 4 pro packs that were donated. Now again, in order to check this, we're going to put these values back into the system of linear equations, which should satisfy the system. So we'll check it out. So we'll do 10 times X, and X is 3, plus 10 times Y, and Y is 3, plus 18 times Z, and Z is 4. And this should all equal to 132. 10 times 3 is 30. 10 times 3 is 30. 18 times 4 is 72. Add them all up, and it comes out to be 132. Let's check the next equation. 8x, which is 3, plus 11y, which is 3, plus 20z, which is 4. And that whole thing should equal to 137. 8 times 3 is 24. 11 times 3 is 33. And 20 times 4 is 80. Add it all up, and it does come out to be 137. So let's try our final equation there. We have 6 times x, again, which is 3, plus 18 times y, and y again is 3, plus 12 times 4. And that should all equal to 120. 6 times 3 is 18. 18 times 3 is 54. And 12 times 4 is 48. Add them all up, and it does equal to 120. So the solution here, determine how many of each pack was donated to the team. X is equal to 3 beginner packs. Y is equal to 3 junior packs. And 4 is equal to, and Z is equal to 4 pro packs. And there we go.